Welcome back, learners. My name once again is Mr. Chilola. Welcome to AS Physics. This is a continuation of our Unit 1, which is physical quantities and units. In lesson 1, we looked at the definition of a physical quantity. We said that a physical quantity is any feature which can be measured, or anything that can be measured, and that a physical quantity has two parts, namely it must have a numerical magnitude or value and a unit. We emphasized that a physical quantity which does not have units is pointless, is as good as meaningless. So each time you make a measurement, you present your result in such a way that it has a numerical magnitude, the size, and a unit. So units are basically determined by the instrument that you are using to determine such a quantity. In this lesson, which is lesson number 2, we wish to look at types of physical quantities. Types of physical quantities. So basically we have two types of physical quantities. Namely, we have what is called the basic or fundamental quantities and the derived quantities. So for the time being, we wish to look at the basic quantities as a type of physical quantities. We define basic quantities as simply those physical quantities that cannot be expressed in terms of other quantities. They are basic. So these are physical quantities that cannot be expressed in terms of other quantities. They are the simplest physical quantities. Usually, you think of these quantities as those that you can measure directly using a measuring instrument. Think about mass, for example, mass of a stone, or mass of a bag of sand, or mass of a coin. In order to determine the mass of a coin or mass of a bag of sand, you simply place this on an appropriate instrument such as a digital or electronic balance. You are going to get the mass of the item right away without having to use several other quantities to combine and obtain such mass. Right, so the instrument will just give you the reading directly, the mass of the instrument. Another one is length. Let's say you are interested in determining the length of a piece of wire. You can measure the length directly, and the ruler will will give you the direct reading or direct value of such a length. So basic quantities, you don't need any other quantities to combine in order to obtain them. All right, so in some cases, basic quantities are referred to as fundamental or base quantities. Basic or base quantities or fundamental quantities. So should you be asked to define fundamental quantities or base quantities, you're basically being asked to give this definition. So these are physical quantities that cannot be expressed in terms of other quantities. So you do not need to divide or multiply other quantities in order to obtain basic quantities. All right, so basic quantities are basically 7 of them. So we have 7 basic quantities in physics or in science in general. There are basically 7 of them. We are going to look at these 7 basic quantities shortly. Okay, you are supposed to know these off by heart. You have to know their SI units. You have to know the symbols of their SI units. It's a requirement. All right. So, as their name suggests, they are basic quantities, so they serve as the foundation for obtaining or deriving other physical quantities. So think about other physical quantities, which we call derived quantities. These are obtained by either dividing or multiplying any 2 or more basic quantities. For example, you're familiar with the concept called speed. In order to find the speed of a body, which is v, all you have to do is combine 2 quantities. For example, you need to divide distance by time. So distance is basically length. This is length. It's the same as length. And then you're dividing length by time. Remember that distance is a measure of length, the length of path. Okay, so length in this case is the basic. Time is also basic. So dividing distance, which is length of path, by time taken to cover it, you are finding a different quantity which is called the speed or velocity. All right, that's very important. So we are saying basic quantities serve as a foundation, a basis for deriving other physical quantities. There are many other derived quantities we are going to look at in the next lesson, which are obtained by combining either 2 or more basic quantities, either by multiplying or dividing them. So let us look at these 7 basic quantities. So the table summarizes the 7 basic quantities. In the first column here, we have physical quantity, and then we have SI unit, and the symbol of the SI unit. Like I mentioned earlier, you're supposed to memorize these as a student, doing physics. You need to memorize these physical quantities, their SI units, and their symbols, because your exam, for example, in paper 1, you may be required to identify the SI unit of a given physical quantity. So it's a requirement for you to memorize them all, and their SI units as well as the symbols of the SI units. So length is a basic quantity measured in meters. So you use a ruler, for example, and use a tape, measuring tape. You can use a vernier caliper. You can use a micrometer screw gauge to measure length. For example, maybe length of a piece of wire. You can be asked to measure, say, length of thread or length of a bench from one end to another, and so on. Length of a ramp, length of just any object that is desired. The SI unit is the meter. All right, the symbol for a meter is small m. Okay, take note. So don't forget, don't use the capital M. If you use capital M, you'll be marked wrong because capital M has a different meaning in physics as well as in chemistry. All right. Then the next basic quantity is mass, which is measured in the unit called kilogram. The symbol for a kilogram is the kg. The next quantity is time. What is the time? Okay, or it may be time taken for an event to take place, the time taken to boil water, the time taken for water to cool off, okay, hot water to cool off, the time taken to cover a certain distance. For example, maybe you are observing the speed of an athlete moving from one point to another across the pitch. So the time taken is measured in SI units called second. Using a stopwatch or any other timing device, you can determine the time an event takes. So you record the time, the quantity, the speed, or the time taken in seconds. The symbol for a second is just a small s. Take note, the s should be small s, okay, because capital S is already being used to mean displacement or distance in linear motion, which we are going to talk about. All right. Then we have electric current. Electric current is measured using an ammeter, and the SI unit is the ampere. Ampere. Some pronounce this as ampere because it's French. So being French, sounds like ampere or just ampere. What is important for me is being able to write it in the correct spelling and correctly when required. The symbol for an ampere is capital A. Remember that in IGCSE you learned that when you are writing down units in full, the first letter, especially those units that are named after people, like current is named, the unit of current is named after a scientist called André Ampère. André Ampère is a French scientist. All right, so when you're writing this in full, like Ampère, the H needs to be small letter. Because if you capitalize the A, it may mean that you're writing down the name of that particular person. All right, but in symbols, the A is capitalized. All right. Another unit, another physical quantity is the temperature, which is measured in units, SI unit called the Kelvin. Also notice that we are using K. K is supposed to be small letter because writing a capital letter here shall mean you are referring to a person called Kelvin. In fact, the unit of temperature was named after one physicist called Lord Kelvin. So the K needs to be small letter when you are writing it in full, but when you are writing this in shorthand, or in short, simply use the letter K, capital. All right. In addition to these five, we also have amount of substance as a physical quantity, amount of substance. You meet this quite a lot in the AS chemistry. Those who are taking chemistry, you also use this physical quantity quite a lot to refer to the amount of reacting substances. All right. So the unit of the SI unit of amount of substance is not the kg. Students usually confuse. Amount of substance is not measured in kgs. It is mass that is measured in kilograms. Okay, so amount of substance is usually given in a unit called mole. The symbol for mole is the MOL. So if you want to write in full, you can write MOLE like this, but in short is MOL. All right. Last but not least, we have this physical quantity which is called the luminous intensity. Luminous intensity is the amount of light produced by a source. All right. So this is measured in SI unit called candela. Candela, it is the word from which we get a word called candle. Candle is derived from this term to mean light. All right, and the symbol for it is CD. So notice that your AS syllabus simply deals with the first 5. So the first 5, length, mass, time, electric current, and temperature. These are used quite often in your AS syllabus. Very rarely do you meet amount of substance and luminous intensity in AS physics. But in A2 physics, these will come up in different contexts. And until then, we can shave them for now until we reach your A2 physics, which is the second part of A-level physics. All right, so once again, the first 5 are dealt with quite a lot in your AS syllabus. So make sure you know these quantities, 5 of them, and their SI units, as well as the symbols of the SI units. The last 2, amount of substance and luminous intensity, are mentioned in the A2 syllabus. So let me emphasize before I go that you're supposed to know these quantities and their units off by heart. You have no excuse for failing to identify them or use them in the context of your syllabus. All right, so having gone this far, let me wish you all the best as we meet again in the next lesson of the topic, physical quantities. But before I leave you, I would like you to answer this question and probably tell me the answer in the comment section. All right, I'll be glad. So the question is saying, what is needed to accurately represent all physical quantities? So you have 4 options from which you have to choose. All right, what is needed to accurately represent all physical quantities? A is saying a base unit and a number. B, a unit and a number expressed in standard form, also known as scientific notation. C, a unit and a numerical magnitude. D, an SI unit and a numerical magnitude. So based on lesson 1 and this lesson, I'd like you to answer this question and share with me the correct answer in the comment section. I'll be pleased to read your answers. Until we meet that time, if you are let me ask you to consider subscribing and of course hitting the notification bell so that you are notified when a new lesson is uploaded. So like, subscribe, and hit the notification bell so that you are not left behind when the new video lessons are uploaded. My name once again is Mr. Chilola, your teacher on this platform. If you have any questions, don't hesitate to drop the questions in the comment section. It is going to be pleasing to me to attend or to rectify anything that I did not make clear. Thank you very much. We meet again in the next lesson of this topic, physical quantities and units. Bye bye for now.